If a pile of sand remains in the shape of a cone whose height is equal to its base diameter while having more sand dumped on the top of it at the rate of 50 pi feet cubed per second, at the instant the height of the pile of sand is 10 feet, find the rate at which the A, base radius of the pile changes, and B, height of the pile changes. It's best to write down all the information given here. First of all, the height is equal to the base diameter, but part A asks us to find the rate at which the base radius of the pile changes, so it's best to put this in terms of the radius. The diameter is equal to twice the radius, and therefore the height equals twice the radius. The next thing given is the rate at which sand is dumped on the top of it, and it's given as 50 pi feet cubed per second. Feet cubed, length cubed, indicates that's a volume rate. V prime, or dV dt, equals a positive because it will be increasing the volume, 50 pi feet cubed per second. And we want to look at the instant that the height of the pile of sand, h, is 10 feet. For part A, we want to find the rate at which the base radius of the pile changes, r prime. We have the rate at which the volume changes, v prime, so we need to relate the volume to the radius. We have a cone, so the volume is 1/3 times pi times the radius squared times the height. In this problem, we have the height is equal to twice the radius, so we can plug that in here. And we have 1/3 pi r squared times 2r. We can move the 2 out front with the 1/3. 2 times 1/3 will be 2/3 times the pi, and then r squared times r will be r cubed. There's our related variables equation. From that, we can take the time derivative of both sides and get the related rates equation. I will indicate the time derivative of both sides with a prime on both sides. Every variable is implicit with time, so every variable will have a prime in the derivative. On the left side, the derivative of v is 1, but then times v prime due to the chain rule. On the right, we have the 2/3 in the pi is a constant. We can bring down the power, subtract 1 from it, and then multiply by the derivative of the inside to complete the chain rule, making an r prime. Every variable will have a prime due to the chain rule. We can simplify the right side so that v prime will equal to the 2/3 and the 3 can multiply each other, and the 3 in the denominator can cancel with the 3 in the numerator. And we have 2 pi r squared r prime. We're trying to solve for r prime here. We have a value for v prime. We also need a value for r. We do not have that just yet. We have a value for h. But we know that h and r are related to each other here. So h equals to 2r. r, if we divide both sides by 2, will be h divided by 2. h is a 10 divided by 2. And 10 divided by 2 is a 5. R will be measured in the same units as height. It will be 5 feet. We now have all the numbers we can plug in. V prime is 50 pi equals to 2 pi times r, which is 5, squared r prime. So 50 pi equals to 2 times pi times 5 squared, which is 25, times r prime. We can reduce these numbers by dividing both sides by pi. The pi's will cancel. And dividing both sides by 25, the 25 on the right will cancel with the 50 on the left, leaving a 2. And we can even divide both sides by 2. I will do that in the next step. So r prime is 2 divided by 2, which comes out to 1. Therefore, r prime, or dr dt, the rate at which the base radius of the pile changes is coming out to a +1, and it'll have units of radius measured in feet here over time measured in seconds here. For part B, we want to find the rate at which the height of the pile changes. So we can relate the height to any of the rates that we have. We have the rate of the volume. That's one way to work it out. But we also have the rate of the radius. And the height and the radius are related in a very simple fashion right here. And that would be the easier way to find the rate of the height. H equals 2r. We can now take the time derivative of both sides. The derivative of h is 1h prime. The derivative of 2r is 2r prime. We can now plug numbers into this. We are looking for h prime, and r prime we just found to be a 1. 2 times 1 is a 2. Therefore, h prime, or dh dt, is coming out to 2. Units of height, also measured in feet per time, measured in seconds, 2 feet per second.